I'm Algebra Annie, and I am here to help you be successful in your algebra class. It always seems impossible until it is done. Nelson Mandela. Our learning targets today are: I can graph a line and write a linear equation using point-slope form. I can write a linear equation given 2 points.
You will recall from our last lesson, we learned about slope-intercept form. You can use this equation when you are given the slope and the y-intercept. So this equation is the easiest one to use when you are given a slope and a y-intercept, slope-intercept form. The equation that we're going to be using today is point-slope form. As you can guess, since slope-intercept form had a slope and an intercept, point-slope form is going to have a point and a slope. So this is our point-slope form that we are going to be using today. The m we know to represent slope. Similar to our last equation, the plain old y and the plain old x will remain as plain old y and plain old x. This needs to have a point in it, and you will notice it had an x1, y1. If you recall, when we had an xy coordinate point, we labeled it as x1, y1 to represent it being the first point. So the x1, y1 come from the coordinate point that we will be given. I want to point out that the rule is to subtract in the point-slope form. So both of these forms will give you a graph of a line. This equation is easier to use if you are given a slope and an intercept. This equation is easier to use if you are given a point and a slope, but they will graph the same exact equation, the same exact line. You can interchange between the two. They're both going to be linear equations. So to do our practice problems, I went ahead and I wrote the point-slope form over here, remembering that there is subtraction. Our slope is always m, and the x1, y1 will come from our x1, y1 coordinate point. So they want us to write the equation that uses both this slope and this point. Since we're given a point and a slope, we're going to use point-slope form. So reading our equation, I've got a plain old y, so I have a plain old y. I'm supposed to subtract, so I'm supposed to subtract. I need to identify my points. So this is x1, y1. I need y1. y1 was 0. The rule then says equal, and I'm supposed to have my slope. My slope was given to me right here. So my slope is 5 over 2. The equation then says parenthesis x. I'm supposed to subtract, and I'm supposed to subtract x1. x1 is a negative 3. So I just plugged in my numbers. Now I'm going to simplify. I have y minus 0. So I have y minus 0 equals, it was the fraction 5 over 2. X minus a negative 3 is x plus 3. And you go ahead and leave it in this form because we want to be able to see the point and we need to be able to see the slope. So now it is in point-slope form, and you're done. So the next practice problem, they want us to write this in point-slope form. Since I'm given a point and I'm given a slope, that will be easy to do. So for my point, let's go ahead and identify x1, y1. My slope is already identified for me. So my equation is y minus, I need y1. y1 was 2, equals, I need my slope. Slope is negative 7, so here's a negative 7. I need my parenthesis, plain old x, minus, I need my x1. x1 is 4. If you are able to simplify this, you need to. There isn't any minus negative to simplify. So he was already in point-slope form, and you're done. So the purpose of point-slope form is where you can still identify the point and it can still identify the slope. Do not simplify this any further down. We're not going to distribute anything into the parentheses. I need to see the point and I need to see the slope. So our next problem, they want us to write this in point-slope form. That can easily be done because we're given a point and we are given a slope. So identifying in my point, this is x1, y1, and I already have a slope. So I need y minus, I need my y1. My y1 is 1. The rule says equal. I need my m. My m is my slope. My slope is 2. And then it's a parenthesis, plain old x, minus, I need my x1. My x1 is a 1/2. If you are able to simplify, you need to. This problem cannot be simplified any further and still maintain the point-slope formula. So our final answer is y minus 1 equals 2, and in parentheses you have x minus 1/2. Point, slope. You need to keep it in point-slope form so we can identify the point and the slope. So you're done. Our next practice problem, we need to put the point and the slope into point-slope form. So I need y minus, I need y1. I have not identified my x1, y1 yet. y1 is a negative 4. So there's a negative 4 equals, I need my m. My m is my slope. So my slope is 0. I need a parenthesis, and the plain old x is minus. I need my x1. x1 is 3. Minus negatives can be simplified down to positives. So this is y plus 4 equals, yes, I know anything times 0 will make this whole thing 0, but you need to maintain the point slope form. The only thing you are allowed to simplify within point slope form is the minus negative. It's the only thing you could simplify. Point slope still needs to be identifiable. So now they want us to graph the line described by the equation. This looks to be in point slope form. I can see a point and I can see a slope. So using point slope form, let's identify our slope and let's identify our point. So looking at our equation, the number in front of the parenthesis is going to be slope. So my slope is 3. To find the point, I need an xy coordinate point. I'm supposed to be subtracting my y. I'm subtracting 1. Since I subtracted 1, my y was 1. Looking for the x, I'm supposed to subtract my x. I'm subtracting 1. So my x is 1. So I'm going to use the slope and I'm going to use the point and we're going to graph. So here's my graph paper. I need point 1, 1. That's going to be where we start. So I start on the point 1, 1. Here is the point 1, 1. Now I need my slope. My slope's not in a fraction yet. Slope needs to be in a fraction. If you throw the whole number over 1, you now have a fraction slope. The top being a 3 means we're going to go up 3, and the denominator being a 1 means we're going over 1. So from the point I was given, I'm going to go up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. I now have 3 points that I can connect on my line, and then I can graph them. So we're done. So this looks very close to point slope form. I kind of have a point, but the rule says I'm supposed to subtract. I'm not really subtracting, which means that this problem was simplified. The only way to get a plus from a subtraction rule was if you were subtracting a negative 3. Everything else looks correct in terms of point slope form. Both of my points are subtracted, and there's a number there for my slope. So now I need to find my point, and now I need to find my slope. So the point, it is an xy coordinate point. I'm subtracting the x, so I'm subtracting 1. I'm subtracting the y, so I'm subtracting a negative 3. The slope is in the number in front of the parentheses, so my slope is a negative 2. But slope needs to be a fraction. You make a whole number a fraction by putting it over 1. The numerator is a negative 2, which means I am moving down 2, and it is over 1. So here is our graph paper. We're going to start at the point 1, negative 3. So here's 1, negative 3. And I need to move down 2 over 1. So down 2 over 1, down 2 over 1, down 2 over 1. Since I have several points in the graph, I can go ahead and connect them. Little arrows on the end, and you're good to go. So this problem almost looks to be in point slope form. The only thing I see that's wrong is that this isn't a subtraction. The rule is supposed to be y minus something. What would I be subtracting to where if you simplified it, it turned into a plus 2? You would have been subtracting a negative 2. Everything else appears to be correct in terms of the point slope form. They're both subtraction. I have a number. I'm good to go. So now I need to identify my slope, and now I need to identify my point. So the slope is the number in front of x, so my slope is a negative 1/2. I read it as negative 1, so that negative is going to be attached to the 1, and the 2 is down on the bottom. The numerator is a negative 1, so that means I am moving down 1, and it's over 2, so I'll be moving over 2. Now I needed my xy coordinate point. I was subtracting the 3, so my 3 is x. I'm subtracting 3. I need my y. I was subtracting a negative 2, which meant my y was a negative 2. So now I need my graph paper. We're starting at the point 3, negative 2. So here's 3, negative 2. And now we have to move according to the slope. Slope tells us to go down 1 over 2, down 1 over 2, down 1 over 2. I have several points on my line, which means I can connect them with a line, and you're good to go. So this almost looks like point-slope form. I don't have a subtraction, so the rule says y minus something. So what would I have been subtracting to would have simplified to a plus 2? I would have been subtracting a negative 2. The rule says there's supposed to be a number in front of here. If it's just a negative parenthesis, it's because it was a lazy mathematician. It's technically a negative 1 parenthesis. Now the rest of it looks accurate. So point-slope form, I have a point, they're both subtracted, and I have a number, so I'm good to go. So I need to figure out what my slope is, and I need to figure out what my point is. So the slope is the number in front of the parenthesis. My slope must be a negative 1. Slope needs to be a fraction. So if I put the whole number over 1, he's now a fraction. The numerator is a negative 1, which means I am moving down 1. Denominator is a 1, so that meant I was moving over 1. I needed my xy coordinate point. For the x, I'm subtracting my x value, so I'm subtracting 2. For my y, I'm subtracting my y value, which meant I was subtracting negative 2. So now we need to graph it. So here's my graph paper. We should start at the point 2, negative 2. And the slope tells us how we get all our other points. We're supposed to go down 1 over 1, down 1 over 1, down 1 over 1. So now that I have several points on my graph paper, I can go ahead and connect them. And then I'm done. So now they want us to go interchangeably between point slope and slope-intercept. So here's our cheat sheet from our last 2 lessons. So they want us to write an equation in slope-intercept form. That would be very easy to do if we were given a slope and an intercept, but we're not. We're given a slope and a point. Since we have a slope and a point, we're going to use point-slope form first. So point-slope form means we need to identify our point, x1, y1, and we already have a slope, so we're good to go. So point-slope form is y minus, I need my y1. My y1 is a negative 2. The rule says equals, I need my slope. My slope is a negative 4. The rule is parenthesis x minus, I needed my x1. My x1 is a negative 1. So this is point-slope form, but I wanted slope-intercept form. So I need to do all of my math operations to make it look like slope-intercept, meaning y needs to be completely by itself. So the first thing I want to do is I want to simplify these minus negatives. So this is y plus 2, minus a negative 2 turns into a plus 2, minus 4, parenthesis, minus a negative 1 turns into x plus 1. So now I'm going to distribute the negative 4 into the parenthesis. So I have y plus 2 equals negative 4 times x is a negative 4x. Negative 4 times 1 is a negative 4. Now I want the y by itself, so I'm going to subtract 2 from each side. Subtracting 2 here, subtracting 2 here. I have y equals a negative 4x minus 6. So let's summarize what we did. The first thing that I did right here is that I put it into point-slope form. After I put it in point-slope, I distributed. After I distributed, I got the y by itself. And then you have it in slope-intercept form. You are able to identify the slope. The slope is the number in front of x, so my slope is a negative 4. The y-intercept is the lonely number without any letter. Negative 6 is the lonely number without any letter. You're done. So our next equation, they want this in slope-intercept form. Both of the equations that we know require slope. We're not given a slope at all. We're given 2 points. So it looks like we're going to have to find out what the slope is. So a quick review, what is slope? Our formula for slope, so I know slope is m, which is rise over run. The rise axis is the y-axis, so you're subtracting the y's. The x-axis is the running axis, so we're subtracting our x's. So we have to have a slope. So the very first thing I'm going to do is I need to find slope. So if I'm going to find slope, the first thing I need to do is I need to identify my x1, y1s so I could actually do the equation. So coming up here, let's do x1, y1. We'll do this x2, y2. So slope is, I need my y2, so I have 2 minus my y1 is a negative 4. x2 is 3 minus my x1 is 1. So this is 2 plus 4 over 3 minus 1. So I have 6 over 2, which simplifies down to 3. So you just found our slope to be 3. So since I have this new information, I'm going to come up here and I'm going to write that my slope is 3. Now that I have a point, I have 2 points actually. I have 2 points and I have a slope. I could actually do point-slope form. You have 2 points to pick from. Just pick one of them and use that one. I'm going to pick the first one. So I have 1, -4 as my point, and I have a slope of 3. So I'm going to put this into point-slope form. So point-slope form is y minus, I need my y1. This was x1, y1. So my y1 is a -4. Rule is equals, I need my slope. My slope is 3. The rule says to parenthesis x minus, I need my x1. My x1 is 1. So I currently have it in point-slope form, but the directions said I needed slope-intercept form. So the first thing I'm going to do is I'm going to get rid of the minus negatives. So this is actually y plus 4 equals 3 times x minus 1 inside of parentheses. Now I need to distribute my parenthesis. So I have y plus 4 equaling 3x minus 3. I need to subtract 4 from both sides. I have y equals 3x minus 7. So this is slope-intercept form, where I could identify the slope. The slope is the number in front of x, so slope is 3. And I could identify the y-intercept. The y-intercept is the lonely number without any letter. The y-intercept is -7. And you're done. So they want us to write this in slope-intercept form. Do we have a slope? We don't. Do we have an intercept? We do. We actually have 2 intercepts. Which is the intercept that we need? So slope-intercept form says we need the y-intercept. So we have our y-intercept. We have our y-intercept. We just need a slope. Well, to do a slope, you need 2 points. In theory, these are 2 points. If you wanted to find the coordinate point to your x-intercept, it was an x, so it goes in the x. The y is then 0, so xy. If you turned this into a coordinate point, an xy coordinate point, it was the y, so there it is in the y. Since it was an intercept, x was 0. So they gave us 2 intercepts, which means they technically gave us 2 points. From these 2 points, we're going to find slope. So I need to identify one of them as 0.1 and one of them as 0.2. So this will be 0.1, these will be 0.2s. So my slope says I need y2, so I need 4 minus 0. My slope says x2, so I need 0 minus a -2. So I have 4 over +2, which simplifies down to 2. So I have a slope of 2. So adding it up here, I have a slope of 2. Do I have enough information now to go into slope-intercept form? I do. Slope-intercept. So going straight into slope-intercept form. Slope-intercept form is y equals. So y equals, I need my slope. You found out slope is 2. Slope is always connected to x in slope-intercept form. So x, rule is to add. So we're adding my y-intercept. My y-intercept was 4. So adding 4. If this can be simplified, you need to. Y always stays at y. 2x is 2x. Plus 4 is plus 4. There is no simplifying to be done, and you're done. So the last problem we're going to do, they give us 2 points. So somehow they secretly know what our line looks like. They pick 2 points on that line. They want to know what the intercepts are for that line that was graphed. So the first thing that I want to do is I want to find the slope. I have 2 points. I know how to find slope from 2 points. So looking at this, I need to identify first. We're going to go ahead and identify this one as x1, y1. We'll identify this one as x2, y2. So doing my slope formula, I needed, so slope is, I need my y2. My y2 is a -12. The rule is to subtract. My y1 is 8. All over me x2. x2 is a -1. The rule is to subtract. I need x1, which is 4. And -12 minus 8 is a -20. -1 minus 4 is a -5. Negative 20 divided by negative 5 simplifies down to positive 4. So my slope is a positive 4. Now that I have a slope, I also have a point. I can go ahead and put this into point-slope form. So point-slope form, the rule is y minus, I need a y1. So here's my y1, it is 8. The rule is to equal. I need a slope. Well, I just discovered my slope. My slope is 4. The rule is parenthesis, plain old x minus, I need an x1. My x1 is 4. Somehow I need to find intercepts from this. I'm going to go from point-slope form, and now I'm going to change this into slope-intercept. So to change it into slope-intercept form, first thing I'm going to do is distribute the 4. So I have y minus 8 equals 4x minus 16. If I add 8 to each side, I end up getting y to be 4x minus 8. Now, if you remember from our earlier lessons, so they're asking for the two intercepts. Well, I have one intercept, slope-intercept form. My y-intercept is negative 8. So I already discovered my y-intercept to be negative 8. But now I need my x-intercept. So to find my x-intercept, I'm actually going to come up here. I'm going to erase all this. So now I'm going to find my x-intercept. You will recall that if we had an x-intercept, we had an x. But since it was an intercept, that meant y had to have been 0. So if we have our equation, and if I know y is going to be 0, we're going to substitute 0 in for y and go ahead and solve for your x. So I have to add 8 to each side. I get 8 to equal 4x. Divide both sides by 4. I get 2 equals x. Well, if x equals 2, then I know my x-intercept is 2. So we found our y-intercept from the slope-intercept form, and we found our x-intercept because we know if we want our x, that means we have to keep x, and y turns to 0. We went ahead and solved for our x-intercept. So this one problem actually puts together everything that we've learned from this chapter so far.
What did we learn today? I can graph a line and write a linear equation using point-slope form. I can write a linear equation given 2 points. And I look forward to seeing you tomorrow in class.